This lecture is going to go over 4 other common problems with regression: measuring the right thing, changes over time, pooling, and functional form. Start with measuring the right thing. Typically, researchers question whether or not they have used the right variable for testing their model when the results they get don't support the model. So they expected something, it doesn't show up, they're like, I wonder if I measured it wrong. Some groups in class proposed a model where health is a function of income and pollution. And they had evidence from the literature that pollution is bad for health, as you would think. Yet the groups found that their measure of pollution, CO2 emissions per capita, had no effect on health, measured as life expectancy. In this situation, the researchers should consider whether CO2 per capita is the best measure of pollution. So that's sort of your first place to go to. I wonder if I measured what I thought I was measuring. CO2, should you use total or per capita? Well, air pollution is a public good, which means that everyone is exposed to it, and my exposure does not reduce anyone else's exposure. And if you haven't learned about public goods, you will soon in intermediate micro. So it makes sense to try total CO2 emissions, since that tells you how much pollution is being generated in your country. Other problems with CO2 measurements. Let's say the researchers do try total CO2 and they still find no effect. Well, it's possible that CO2 blows around, so where it is produced is not a good measure of how much pollution there is. Sometimes you just don't have a great measure for the concept you want. The only thing you can say is that for the measure you had, there was no effect. You can't say for sure that it's not a problem because you know there are problems with measuring. So what I'm trying to say is that even if your model, the regression rejects that there's a relationship between pollution and health, that's not the final word, especially because you know there were problems with how you measured pollution. But remember, you don't have to fix the problem. You need to acknowledge it and think about how it might change your conclusions. Next topic is changes over time. It's possible that the relationships you estimated have changed over time. This is probably not a big issue in your project because the data are just a few years old. But it can be a problem if you're trying to make claims about things now based on older data. Pooling. What if the relationship you are testing applies strongly to poor countries and doesn't apply at all to rich countries? When you pool all the countries together, the regression analysis gives you the average relationship for both sets of countries. Okay, so let's see how this might work out. Figure 1, all of these figures show the effective income on years of schooling for low-income countries. And if you look at the source, I made these up to show you to illustrate this problem. Okay, so if I just look at the poor countries, as in Figure 1, I have a pretty steep relationship between income and schooling. As income goes up, I see a sharp rise in education. And for a lot of things, after a while, income kind of levels out. So if you look at Figure 2, I'm looking at richer countries, and the relationship is flatter. I have more income. It doesn't really increase schooling much above 9 years. Whereas in Figure 1, I go from 4 years to 6 years with just a little bit more income. All right, so what happens in Figure 3 if I have both of those sets of countries together? I'm going to get a regression line that's somewhere in between those two relationships. So I'm going to miss that the relationship is really strong in poor countries, and it's not going to be quite right. So you can lose information when you pool groups that really aren't the same. And there's an easy solution to that, and that's to run regressions on subsamples, which you can do, like you could sort your data in Excel by income, and then just capture the lower income ones if you think that's where you really expect the relationship that you're measuring to hold. Functional form. The last possible issue is whether you are estimating the correct functional form. Remember when you had a scatter plot and you had to choose the best trend line for it? Did you choose a nonlinear trend line? If so, you might get a more accurate estimate if you use a nonlinear functional form in your regression. So instead of just y is equal to beta 0 plus beta 1 x1 plus beta 2 x2, you could square your x1 variable. So you'd estimate y is equal to beta 0 plus beta 1 x1 again, but then you'd also include a squared term. And what that will allow you to do is it will allow, for example, y to increase with x, but at a decreasing rate. And if you're interested in trying that out, let the instructors know, and we can help you work with that. Okay, next lecture is Writing Focus for Writing Assignment number 3.